Okay. So, good morning. Not that many people asked yesterday, but I have a pretty technical and hopefully interesting topic. I'm talking about integration Plone with eXist-db. eXist-db is an XML database, and we are currently in a project where we just have content in Plone and moving the stuff out to an XML database. Just to introduce myself, that's me. I'm a long time Python and Plone nerd. I'm coming from the publishing business. I've been working in several publishing houses since the mid-90s. And beside that, I'm also doing diving. In my former life, I was a church musician, and I'm still a singer in a professional choir, so there's some life besides Plone. But that's not my topic today. I'm talking about XML-based publication workflows in the context of having a workflow going from docx, so basically Word documents, to XML, and then from XML to PDF and EPUB. And I'm talking about the integration of Plone with eXist-db, which is an XML database. So what is structured content? Structured content, of course, it's XML. Right now in the project, or as you know in Plone, we are using HTML for storing content. So the content that is managed in Plone through TinyMCA or some other editor is basically HTML or HTML snippets, and I wouldn't call that a structured content, although it's markup, but as you know, most of you, the markup of TinyMCA is basically crap, and we can do that for professional publication. So what's the advantage of using XML? XML is industry standard. We can define the structure of XML documents using XML schemas or old-style through document type definitions. There are lots of tools on the market for defining such XML schemas, for performing validation on the data, either syntactically or using the semantics that is defined by the XML schema. And especially in the publishing world, XML is a per se standard for publishing. So basically all large publishing housing are using XML in some way or in the other way for managing their content and then converting the stuff into different channels like HTML or PDF or EPUB, EPUB3 and so on. So in this project we're doing basically the same with the old content. And I'm giving an overview of the project a bit later. I'm just trying to explain what database we're using. So we have been looking at various databases in the XML field. There are not that many. There are basically two reasonable open source XML databases. One is eXist-db, the other one is BaseX. And then there is not much more available on the market except in the professional world. There's MarkLogic application server, and then we talk about license costs in the 10,000s or even 100,000s. So eXist-db defines itself as a NoSQL document database and application platform, but to make it short, it's an open source XML database written in Java. You can store XML and HTML documents inside, so basically stuff that's markup with the parentheses, but you can also store arbitrary binary data like PDF documents, images, and so on, which is pretty neat because you always have a document containing text, so you can convert to XML, but the document can also contain images, and storing the same data, XML and all assets in one database is pretty fine. It's based or supports the most current XML technologies like XPath3, XForms, XLT, XGRADE3 and so on, and it also comes with the scene for full-text indexing, which basically provides you with a very powerful and enterprise-style level full-text search comparable to what you have on Google. And if you need, you can just add other Java XML technology, for example, stuff like schematron for performing validation checks and so on, reporting. So it's pretty open and extensible. It's Java, but it's completely solid and working. The nice thing about eXist-db is it fits the Plone document structure perfectly, because it uses all internally also a collection approach or folder approach. So basically you can just structure data as in Plone in terms of folders and folders, nested folders and so on. And we will see later how this fits into Plone, traversal and so on. One very nice feature is that you can access the database directly from your computer, either locally through RepDuff. So basically you can just map the database or part of the database onto your local file system on your Mac, on your Windows, and just modify, write and read data into eXist-db just by drag and dropping and so on. You can script the database using xquery. xquery is a scripting language specifically designed for XML, and the nice thing is they can write scripts within the database. The scripts generate XML, and there is some internal magic to transform the generated output XML into either JSON, HTML, or XML through serialization. So, and these particular scripts are just exposed through REST API. So you can make a HTTP call to the database, call the script, and say, okay, I want the result as JSON or serialized as HTML. So that's pretty neat for integrating the database into Plone. Especially when you're working with JSON, you just get the data directly in the right format. You don't have to work with the XML on the Plone side. You get JSON. So how would you use it? eXist-db, just, okay, we store documents, we index the documents, of course using the search, aggregation, and manipulation of XML documents. So the project I'm working on since almost 4 or 5 years is Oncopedia. Oncopedia is a medical portal for medical guidelines for the diagnosis and treatment of hematology and oncology diseases. And the basic workflow is stuff like we have authors, doctors working in the field of oncology. They write guidelines. They are mandatory for the treatment in Germany or in the German-speaking world. As Word documents, in the current workflow, we import the stuff into Plone, convert the stuff through HTML, and then we have a workflow from going from HTML to PDF and, of course, online to HTML. This is based right now on my own produce and publish platform. You might know it's basically said in 2 words. We take HTML as input and use CSS for styling, and both technologies, HTML and CSS for styling, generates a nice PDF. I have some assembled later. And the portal is owned by the German Society for Hematology and Medical Oncology, which is basically the medical society in the German-speaking world for these diseases. So these are some screenshots of the portal. We have basically 3 or 4 sections. It's only in German right now. We have a new version which basically also includes an English version. So it's basically grouped by the audience. The Leitlinien portal is basically the focus for medical personnel. Then we have a section for the patients and a section for caretakers. So this is a subsection. This gives you an overview of the different diseases or the different guidelines. I cannot translate all these diseases to English. The names are too complicated, so just forgive me. But this slide basically shows you an example of one particular guideline. As you can see on the left side, we have a pretty long or deep structure. And it's basically lots of text. The document has a fixed structure. Basically, every guideline for every disease has basically the same structure. We have stuff like workflow, not kind of workflows, but diagrams that are currently coming from the Word documents. where basically a doctor can look, the doctor knows, okay, this patient has some disease, and then he can look into, okay, this disease is just at the starting point, or the patient is already dead, and then he can just make a decision about medication and so on. And these guidelines basically just give information about the disease, the treatment in the state, the various states of the disease the patient is. We also have pretty complex information about studies, medical studies for particular disease. This is especially a reason why we are going from HTML to XML, because we have requirements from external applications where other applications are interested in particular information. For example, a clinical information system would be interested in getting particular information about the treatment of a particular disease with a particular medication. So we have some studies, and you can see lots of numbers, and right now we cannot, we don't have any chance for marking the information in the original document in order to extract the information that we need for the external systems. Then we have the PDF output of the guideline. It's basically that what comes from the publish output. It's the cover page. Then we have an auto-generated table of contents. The contents looks like this, pretty boring, lots of text, and sometimes an image. And at the end, we usually have a pretty long list of citations and bibliographic information. So this is always handled right now in Plone. The workflow looks like this. On the left side, basically, the author, as I said, are some doctors in the field of particular disease, and they write the guideline. Then they pass the document at some point to the internal editors. They perform some consistency checks on the document, check if the structure is right, the numbering is right, and so on. They add some references to the bibliographies and so on. So the doctors are basically, they know how to use Word, but they are not the perfect technical writers. So internally, we just update the document and bring it into some consistent state, and in a state where we can say, okay, we can just import the stuff into Plone and then perform an automatic conversion and processing on these documents. So in the workflow right now, we are going in the first step from Word to XHTML using OpenOffice. And then we have several iterations internally for doing stuff like fine-tuning on the contents, imaging, image maps, internal linking. Then we have the process for the conversion to EPUB and PDF. And in the last step, we do the publishing. This is status quo that we have since 2010. But now, since about half a year, we're actually in the progress from changing this workflow from docx, from HTML to XML, because we just figured out that HTML as a foundation for doing professional publishing is not usable anymore, because for several reasons. We don't have a well-defined structure on the document. We can perform validations. We don't have options for restricting the structure, for adding additional semantics, for example, for identifying certain links as links to, let's say, PubMed, which is a large medical database for publications and so on. So basically, we're currently in the progress to going to XML. Another reason was also that the current implementation is very tied to Plone itself, and it contains lots of fragile and workaround code grown over from Plone 4.0 to 4.3 with stuff like handling images in Plone, exporting the stuff, and so it became a pretty mess over the last year. So it's basically maintained it to death until now, and we were at the point where we couldn't fulfill any more new requirements without taking duct tape and wrapping the stuff around Plone and so on. And so it was time to start from scratch and go to XML. And as said, we had requirements from external vendors that had been interested in our data, and we basically couldn't fulfill their requirements with the current implementation. So we right now are on XML, and our current document structure in eXist-db looks like this. Can you read that? Hardly, I guess. Yeah, I have to stay with the microphone. Mouse pointer is not appearing. Okay, basically we have in eXist-db a document structure like this. We have on the left the root node, and then we have basically on the first level separation by language, so it's German and English. And then on the second level we have categories like Ongopedia, MyOngopedia, and Ongopedia P. And then, not sure if I can carry that around with me. We have the language, then we have the category, and then we have the guidelines. And then every guideline has a particular workflow, draft, count, and archive. Okay. Yeah, perfect. Yeah, okay. So we have, for one particular document, we have multiple versions of the document. We have always a draft area where basically the document is imported in. This one is has subfolders for the incoming document. Then we have a directory for the XML, for the generated HTML, a media directory, and a directory for the generated PDF. And then we have always, upon publication, we will copy this structure into the current directory. So basically, when the editor makes conversion, then see, okay, the document is okay, it's consistent, all validations pass, and so on. We perform the publication to the current state, and associated with that we have an archive of older versions, so there's always an archive directory with a subdirectory for the different. So in Plone we have, now we come to the integration part. In Plone we have something called a connector. A connector basically is a persistent object, is a dictionary content type, pretty small. And you can just create an instance of the connector at any point in the Plone side. And this basically represents a subtree within the database. So we have one connector for the draft, one for the current publication object, and we have one for one archive version. But you could also have a connector on this level and then just map the stuff into Plone. So basically, just a connector just maps a subtree of eXist-db into Plone, consider it as a mount point. What you see here is basically, in Plone you have then the path to the connector to this point. So basically, the connector is represented through this URL. And then you can just reference content within eXist-db by just adding the subpath, for example, XML/index.xml as part of the subpath in Plone. So you can basically just have a full URL that represents a path in the Plone, and then at some point the traversal continues in eXist-db. So to summarize that, perhaps I have time, it's 10:30, okay. I think we have time to give you a demo on that later. That makes things perhaps a bit more clear. Though the connector is basically adjusted very tiny Plone content types based on dexterity, and perhaps you can compare it to Reflector. Anyone using or knowing Reflector from Plone? Reflector is just something similar where you can just map a file system path into Plone. Let's say you have a large collection of videos or images within on the file system, and you don't want to import the stuff into Plone. But Reflector gives an option to just say, okay, here's a folder on the file system, and then you have some object, and then you can traverse into this Reflector and then access the file directly from Plone. With full traversal support means you can just traverse to the object and then traverse from the object into the subtree represented by the connector. I have a small UI for adding collections. I have integration of the ACE editor. It's pluggable with the registries. For example, in the eXist-db you can have various data like XML, HTML images, and you can just register a particular view for performing either a standard operation for downloading the stuff, for binary data, or for viewing images and so on. It is possible to import zip, the data as zip, and export the data as zip. We have an API for calling scripts from the database directly through the REST API. And it's pretty small and extensible, and at any level the complete Plone security and rights management applies. It's 10:32. I think I give you just a quick demo, which makes things a bit more fun. So as I said, the complete database is exposed through RepDev, so I just need to move this one here on this window. So that's the URL of the database, the path. I can just say connect, and okay, yes, just open the windows on the different monitor. So now you see the top level structure of the database mounted as local file system on my Mac. So we have this Onedia directory here. We see on the first level the languages. I can go into second level and then take one particular guideline. You see that it will take time to reach the complete subfolder for guidelines. So I could, for example, when you're going to this, you see the structure that we have the current document, and you see the subdocuments. So it's pretty easy just to have to interact with the database, because you can just you could use your local Oxygen editor or stuff like that for just doing the content management either on the local on your local machine if you want that. But in our case, that's not the case, because we are just trying to hide also complexity from the address, because we are trying to have a complete, fully automated workflow. So the Plone integration, I just have to check where my browser is. Okay, so that's one of these guidelines in Plone. Where's my mouse pointer? Here it is. So that's one of these guidelines. It's German. It starts with the definition of the disease, prevention, the clinical picture of the disease, and so on. You see lots of medical stuff. Don't ask me about details about the content. It's pretty long. And the bibliography. So let me scroll back. So the interesting part with integration is the XML browser. So you can see here now that we have you have a view from Plone onto the database to a particular subtree. And the same structure as you've seen on the on my local file system can see here. So I can just click here through the collections or subfolders. And for example, in the HTML folder, I have the converted index XML file, I have the extracted assets with the images and so on. And for example, I could just perform some basic convention on the XML through the web within Plone using the ACE editor, if I want to do that. But it's just a very tiny XML editor. I wouldn't use that in production, though it's just for making some smaller changes. But it was basically kind of proof of concept, and it's actually working very nicely. Something I want to show, for example, let me find the other window. So I'm in the guideline Prostatakarzinom. I'm a bit confused because I don't see here what I'm having. What is it? It seems to hang because thinks there's a problem with eXist-db and WebDev integration in Mac Yosemite. Though the former version with WebDev on Mac OS 10.9 was working much more smooth than this version, so it's hanging. So that's perhaps related to Mac and not to eXist-db. So from within Plone, you could just, for example, where's the mouse pointer? Here. I could just create a new subfolder for the Plone conf, and if the integration with Mac would basically work, could instantly see that the folder would be created on the local file system. So it's just pretty easy to work either directly in Plone or on the file system or in parallel. And for this particular project, we had been adding an additional user interface for doing all the conversions. It's hanging for some reason. Or is the network not working? It's just waiting for the server. No idea. Perhaps a problem with the network in total here. So okay. It's okay. So it reloads the page and it created the sub collection. And all I'll show you is basically work in progress. We're not in production right now. This is basically an application built on top of the connector particular to this particular project. We're basically showing a subset of the contents of the eXist database. Then we have some option for uploading the docx document. Then when the eXist document would exist, there would be a button for doing the conversion, then a button for doing the publication, and then a button for doing the conversion to PDF. So the use cases of eXist-db within Plone are when you have a amount of existing documents that you want to have in a database. It's basically an easy way to just have the stuff in the database and just mounting the stuff into Plone. It's not a replacement for storing Plone content directly into as XML in an XML database. There had been approaches in the past with archetypes, XML storage, where we had some mapping from the archetypes fields into some XML schema. It's not doing the way. It's not a transparent replacement for any kind of storage we have. It's just you have bunch of documents. You want to put stuff into a database. you want to use XML technology in the database for performing queries, updates, and so on, but also having the ability to use the functionality and the documents in a pretty transparent way within Plone. It's not fully transparent, but it gives you a traversal support. You can just access all files in Plone. Through Plone, you can just apply all kinds of security management through Plone. So it's pretty transparent, but not completely transparent. And the overall architecture looks like this. The central point is still Plone as CMS. It is accessed in two ways. Originally by the anonymous site visitor and of course by the internal editors. Then we have two web services. One web service is performing the conversion from docx to XML. And then we have the traditional Bristol platform that I wrote years ago, which is doing the conversion from HTML and CSS to PDF and EPUB. And then we access the eXist database through standard protocol WebDAV and HTTP, so the REST API, and it returns JSON, HTML. Oh, I have this is in a bit more assumed way. I forgot that. So. The content of eXist-db through WebDAV and use this approach for local editing tools. And then in a further version that is scheduled for sometime next year, we want to provide some kind of public API or API servers for medical applications, medical databases, or clinical systems, where we intend to provide some kind of REST API through perhaps a pyramid service that directly talks to the database that would not go through Plone. Just one side note, anyone heard of PyFile system, a module in Python? Just a hidden gem. We have been using this module pretty heavily in the project. The module provides you a transparent access from Python to various file systems, either local, WebDAV, Dropbox, network file systems that we access through SFTP, SSH, or you can access S3 or even Plone. I have a small prototype. We can write code accessing some kind of file system with a unified API, and your code doesn't have to know about either its local file system or stuff like that. You can just give it a, for example, in this case, I have just a pretty dump code where basically you have a handle through the URL. For example, this points to the Raptor server of eXist-db. You run the handle. You can, on the handle, call something like list dir. It gives you just the names of the current files in the folder, and that's completely independent if it's Dropbox or local file system, stuff like that. And you can just manipulate files. For example, in this case, I can just write to eXist-db with the handle.open as you would do it in Parser Context Manager, and that's pretty fancy. For example, when you write code for some importer or exporter for doing an export from eXist-db into a zip file, you just open the input file using the zip handle, you open the output file in the same way, and then just you call walk on the input handle and then just write stuff into the other code. And that's completely independent of the underlying implementation. So this could be either on a local file system, it could be WebDAV, or could be stuff like that. And that's pretty handy. So the conclusion for this project or for this talk. Using XML, we reach much better or much higher production safety using XML, because we can, at any point, we have a well-defined structure, hopefully. We can validate the XML, we can perform checks, we can perform transformations and so on. And in particular, we could replace lots of Plone-specific code for dealing with images, image scales, and so on, or Plone bugs that just stacked over the last years. And the code base right now is much more smaller, much cleaner, much more easier to test than it was in the current state we're using right now. We have a pretty well-defined conversion workflow going from Word docx to XML. We're using our own XML schema specifically designed for this particular project. We're not using docx or stuff like that, because we have specifically requirements for the semantics of the document. So we defined our own schema and have an external web service doing the conversion from docx to XML. And as said, the code base is much smaller, and it's pretty easy to build XML application on top of that. For example, Sally Kleinfeld yesterday announced that we want to talk to more about bibliographies. There's also an XML standard for bibliographies from the Library of Congress. This could be an approach for managing bibliographies in Plone. I got a call also yesterday from guys from the University of Lyon, which have some workflow from XML into Plone based on some scripting running into the Oxygen editor. And I think there are a lot of ways or a lot of options for using the stuff with Plone, but having a separation between Plone and the data on the database. So, any questions?
If and how do you support search from Plone? Because you've got a lot of many different versions in different formats stored, and then if a user searches through the portal, he or she might end up with one of many versions of the same document.
The connector by itself right now doesn't contain any integration with search. For this project, we just added an indexer using collective using Plone indexer, which just indexes the XML document represented by one connector. So one connector basically represents either the draft version, or we have a connector for the published version. So if you index one connector for the draft version, we have this stuff as searchable text in Plone. So we just search for one stuff, and for the public search, by default we only search through the published documents, because the draft documents are private internally. And search by archive is basically just an additional query parameter in the underlying search form. So it's pretty integrated. We are looking perhaps into options for using the internal Lucene-based search, for having some better ranking or some much more fine-grained possibilities than we have it in Plone, because the Plone full search is pretty dumb.
And the same question could go for example, relations. If you have some Plone content and you would like to reference somewhere inside the...
I didn't tell you that, as we have also a relation between documents. There's one big guideline, then we have, for the same topic, we have medical studies, certification documents, and so on. So they basically share internally the same metadata, like the medical topic. And then we can perform some searches where you can basically have references from the guideline either to the archive, or from the guideline to the medical study certification and so on, or have links to the archived versions. But that's always happening right now on the Plone level, because we have a copy, we maintain the same metadata in Plone and on the XML level. But for the phase 2, where we interested in just attaching external services, we basically then use the internal metadata within XML. Everything else right now on the portal is based on the metadata in Plone, but it's just a one-to-one copy. So at any point, the metadata in Plone is the same as in XML. There's a micro.
So you're using PyUno for the docx to XML?
We are using right now for the conversion to HTML OpenOffice. This was implemented by Uli Fouquet, also a long-time Plone contributor, and is basically running the stuff as black box as a service for us. So I think it's using PyUno in some way, but as I said, for the new version, we are going completely away from OpenOffice because OpenOffice conversion is basically a pain in the ass for several reasons. With every version of OpenOffice, you got new markup, you got new errors in the markup, and so on, and it's completely unusable for the new version. I know that OpenOffice can convert to not OpenDoc, DocBook 4, I think, but as I said, we have our own XML dialect, and so we have a partner company in Germany doing the stuff as a web service, and it's. I made the experience that conversion to DocX from DocX to something there's no product on the market that works reliably, and all publishers have their own handwritten conversion from DocX to some internal format, and then they have their workflows for going from this internal format XML to, let's say, XML for publisher, Elsevier or publisher, Springer, and so on. That's basically how the conversion from DocX works in reality on the publisher side or on the preprint services side.
You just answered my next question. If that's are there problems converting DocX? There's a lot of problems.
Yeah, and there's a tool on the market that works in a reasonable way for us, because especially when you're having a very dedicated schema type definition.
My question was basically the same question anyway, but in addition, is the metadata you're storing in the XML, presumably, is that extracting from the docx, and how do you then get doctors or the editors to present that in there?
Okay, we have been discussing about what is our metadata. In the first approach, we had, how you call it in English, a format template for Word where I could just add metadata, authors, medical topics, and so on within docx. But we give that up, and because the workflow right now is basically the internal editors going to Plone, create a new document, and they want to stay within the Plone world. So that we have just a news interface where you can just add the metadata as part of the dictionary content type through behavior. And then we, at the point when we convert the document from docx to HTML and XML, we just write a small XML file. This goes to the converter, and this one also adds some cover pages to docx in order to have this information available as part of the docx document. But we don't perform any extraction because it's much easier for the editors staying in Plone, having one space where you can just upload the stuff, click on the button for conversion, then make the checks, look at the document, performance conversion from XML to PDF, and then publish. So basically, keeping it as simple as possible, having one tool, having one user interface for that. Other questions? Okay, then thank you very much.